This geocache calls home when opened, and the symbols to unlock it are hidden somewhere in this video. Pay close attention and comment below if you manage to find the combination. A geocache is basically a hidden container that people find using GPS coordinates. Some are simple boxes with a note, and some are larger containers with items inside. My plan is to build a more elaborate geocache with a combination lock that also sends a signal home when it's opened. The problem is that it has to survive outside, be battery powered, and capable of sending a signal far beyond the range of regular Wi-Fi. And that's where this LoRa module comes in. It was sent to me by today's sponsor, Reax Technology. LoRa is made for sending tiny messages over long distances, not fast, not a lot of data, but perfect for sending a quick message like this. To test it, I made this receiver that stays at home and this battery-powered transmitter that I can bring outside. Every time I press the button, it sends a short message back home and I get a notification on my watch. Inside is the LoRa module, a microcontroller, a button, and some regular AA batteries. I'll put the code and files on Patreon for anyone interested in more details. It works on the bench, but if the range is only 50 meters, this whole idea is pointless. So let's take it outside and see how far it actually reaches. So the plan is simple. I'm going to take a walk along this old railway track, do some LoRa range testing along the way, and hopefully find a good place to hide the geocache. So we're currently around 100 meters away from home, and at this location there's quite a bit of vegetation that could block the signal. Let's press the button and see what happens. And I just received a notification, so at this location there is no problem at all. There is actually quite a few snakes in this area, so I'll try not to stray too far off the path. We're now at around 400 meters away from home. And I just received a notification on my watch, so it works fine in here as well. I'll take a closer look at this area. There's actually a nice gap between these rocks where the box could be hidden without being too obvious. This is a good candidate, but let's push on a bit further and see how far we can actually go. Right now we're close to 600 meters away from the home unit. As expected, it works fine in here as well. But it's steep on both sides, and I guess this fence means they don't want people climbing up here. So even though the signal works, this probably isn't the right location. Still seems to work fine around 800 meters away from home. But it's mainly trees and vegetation in here, so I can't really see any good natural cover for the box in here. Still working around 1.2 kilometers away from home. But just like the last location, there's not really any good places to hide a cache in here. This old bridge is around 1.8 kilometers away from home. And it seems like we're now out of range. But considering how small this antenna actually is, I'm already impressed by how far we managed to push it. Now that the signal can reach home, I can start building the actual geocache. If you want to see more projects like this, consider subscribing and turning on notifications so you don't miss the next one. For the actual build, the outside will look like a small treasure chest. But 3D printed plastic is not exactly known for being waterproof. So I bought two small sealed plastic boxes that I will place inside the chest. One is for the electronics with the ESP32 LoRa module, batteries, voltage regulator, and capacitors mounted in a small 3D printed frame. The other box is for the actual geocache contents. The chest itself is printed in several parts. First, there is the main bottom section. Then I designed this inlay frame, which hides the electronics box. It also has a slot for the user accessible box, so that it can be taken out when the cache is opened. The microswitch is also mounted on this frame, so we can detect whether the lid is open or closed. When someone opens the lid, the switch is released, the ESP32 wakes up, sends a short message, and then goes back to sleep to save battery. The lid is printed separately and attached with regular metal hinges. The lock system uses 3 rotating dials with symbols instead of numbers. Each dial has 8 positions, which means there are 512 possible combinations in total. To make the dials snap nicely into place for each symbol, I'm using magnets. I placed 24 magnets on this plate and mounted it right behind the dials inside the box. Each dial has a matching ring with 8 magnets. So when the dial turns, it clicks neatly from one symbol to the next. It's probably a bit overcomplicated, but the magnetic clicking gives it a high quality feel when turning the dial. Each dial has a small notch on the back. When the correct symbol lines up with the release point, the lock can open. I also added a fully 3D printed QR code plate to the front. The QR code sticks through the case and is attached from the inside with a small plate and screws. The code is for those who finds the box, and it leads directly to this video. I added a handle on the side just to make it easier to place and remove the box from its hiding spot. The inlay frame with the electronic box slides neatly into place and is secured with a few screws. So when opening the lid, I should now receive a notification on my watch. And it's working exactly as planned. I printed a few coasters as souvenirs, placed them in the user box and dropped it into the chest. I'm now heading back to the spot I found during the range testing. Before placing the box, I'll just do a final test to verify that everything is working. I opened the box and shortly after I received a message on my watch. I placed the box between the rocks and also added a couple of smaller rocks to cover it even more. So it's fully functional and you should soon be able to locate it like any other geocache.